What is a regression analysis? Why do we use it? What are its underlying assumptions and what are its limitations? Hi, my name is Fabian Fröse. In this video, I will talk about these issues. Let me start with an example. I like donuts. They're very delicious, yet they also contain a lot of fat and sugar. So the question would be, how much weight do I gain from eating donuts? And that can be tested by regression analysis. Have a look at this chart. You see on the x-axis, on the horizontal axis, donuts consumed. And then you see on the y-axis the weight in kilogram. If you look at the figure, it looks a little similar like a correlation analysis. You can see an upward trend. The more donuts I eat, the more weight I gain. Regression analysis can do more than just correlation analysis. It can include different variables. Not only donuts are very delicious, so are cupcakes. Let us add cupcakes to this picture. Here we also can see the more cupcakes I eat, the more weight I gain. And I've plotted also lines so you can see it's an upward trend. Relationships between two variables analyzed via regression analysis. So far you could see that the more donuts, the more cupcakes you eat, the more weight you gain. But there are also other things that could lead to weight loss. Take the example of exercise. I like running. The more you run, the more weight you will lose. So we have a downward slope. After going through the examples, now let me provide a more formal overview of regression analysis. The definition could be as such: a way of predicting an outcome variable from one predictor variable, which would be simple regression, or several predictor variables, which we would call multiple regression. And regression analysis also allows us to add control variables that can reduce the confounding effect of other variables. Let us think back of the example. Donuts, maybe the main question was how much weight do you gain from eating donuts? Simple regression. Or multiple regression, you have donuts and cupcakes. And the control variable would be sports exercise, running. Because even though some people eat a lot of donuts, but they do a lot of exercise, they do not gain weight. So it would be important to control for these factors. Because some people, they eat a lot of donuts, don't do any sports exercise, they gain a lot of weight. If we only have these two cases, the conclusion would be eating donuts would not lead to gaining weight. So we have to be very careful, and adding control variables would help to eliminate such biases. The main objectives of regression analysis can be maybe summarized by two main objectives. First, regression analysis allows us to establish if there's a significant relationship between variables. The second one would be also based on regression analysis. We can also develop some forecasts for future observations. That makes regression analysis a very useful and powerful statistical analysis. That's also one of the reasons why you read and see so many papers that use regression analysis to test their hypotheses. I've already mentioned correlation analysis. I have another video on correlation analysis. In this video, I talk about regression, or more specifically, linear regression analysis. Now let me briefly compare correlation and regression. Correlation would be typically a degree which two variables are related. In contrast, regression analysis would like to develop the best line of fit between an independent and a dependent variable, or between a predictor and an outcome, x to y. Correlation does not provide such a fit line through data points. That's what regression does. In regression, it's also more often used when you manipulate certain variables, or you look at different points of data of certain variables. Another distinction is, a major one, is correlation. Usually you only measure two variables. Remember, bivariate correlations. You put two variables into relations. In regression analysis, you can add multiple variables as independent variables, and you can also easily add control variables, which is not the typical case in correlation analysis. If you would like to run regression analysis, you can use various programs. Nevertheless, I think it's also important to know the underlying equations. They're rather simple. In simple regression, you have y equals the constant, if x is 0 or beta is 0, plus then you have the beta value and the x value, plus then also the error term. In multiple regressions, then you can simply add different x's and betas, and then also corresponding error terms. There are certain assumptions of regression analysis that need to be met so that we can trust the results. One is normal distribution. The data should be normally distributed. Another one would be homoscedasticity. That means residuals at each level of the predictor should have the same variance. There's a test that you can run, Levene's test, for homoscedasticity. If you fail to meet this assumption, this can invalidate the test results. What can you do if you face such dilemmas? You could transform data. I have a video on data cleaning and preparations. Find more inspiration there. Or you can also run a Wilcoxon test. From a perspective of an applied statistician, we would usually say, if you run regressions and you have large samples, even violating these assumptions would lead to fairly robust results. There are different methods of regressions. We have hierarchical regressions and stepwise regressions. Hierarchical type of regressions refers to entering predictors based on prior research. The researcher would decide which variables to enter first or in which order. In contrast, a stepwise regression is based on mathematical criteria. It could be forward or backward, stepwise adding variables. For applied researchers in marketing, business, psychology and so forth, the hierarchical method of regression is the typical way of running regression analysis. I talked about different assumptions underlying regression analysis. There's something else that is very important to consider when running your regression analysis, and that is multicollinearity. And multicollinearity refers to a strong relation between two or more predictors in a regression model. So that could be that certain predictors are highly correlated. And if so, this poses serious problems for the results of the regression analysis. It could lead to completely wrong and untrustworthy beta values. It could also affect the R square and the R. And it could change also directions, plus and negative. So essentially, we cannot trust the results at all. So it would be very important to check for multicollinearity. What you could do to do so would be, you can look at the correlation analysis. If there's any very high correlation, let's say above 0.8, between any of the predicting variables, then that could be a reason for concern. Then there's also more specific test statistics, such as variance inflation factor, if that is larger than 10, or tolerance statistics, if that's below 0.1. And that would give serious concerns to multicollinearity. Now we've reached the end of this video. Let me conclude this video. Regression analysis is a very common and very powerful statistical analysis. It's very often used in different types of research fields because it can establish relationships between different variables. It can also control for confounding effects for control variables. For for all these reasons, regression analysis is frequently applied in research. Alright, that's it for today. Thank you. Bye bye.